Yeah, thanks, Varun. Okay. Right? N factorial divided by 4 factorial into n minus 4 factorial. This is equal to 2 by 1, right? So you're asked to find the value. You're asked to find the value of what? You're asked to find the value of n. Now see this. If you see this, right, we can write it like this. I'll just write it. Okay, I can write it like this. N factorial. N factorial. What is happening today? Yeah, n factorial. What is happening? N factorial divided by, this is 2 factorial into n minus 2 factorial. Now, when we talk about this division, it will be converted into multiply 4 factorial into n minus 4 factorial divided by n factorial, right? Right, everyone? Now, this is equal to what? This is equal to 2 to 1. This is equal to 2 by 1. If you see this, n factorial will be cancelled. Okay. Now, tell me, out of n minus 4 factorial and n minus 2 factorial, which is bigger? N minus 4 factorial, right, is bigger, or n minus 2 factorial is bigger? Just put the value of n, put anything in place of n, and you will just get the answer. Yes, very good. N minus 2 is bigger. N minus 2 is bigger because put n is equal to 6. 6 minus 2, 4 factorial. 6 minus 4, 2 factorial. So obviously this is bigger. So this can be written as n minus 2 into n minus 3 into n minus 4 factorial. Yes or no? Because see, put n is equal to 6. So 6 factorial can be written as 6 into 5 into 4 factorial, right? Got it? Just see the example. If you put n is equal to 8, n minus 2, 8 minus 2 is 6 factorial, which can be written as 6 into 5 into 4 factorial. That's why n minus 2 factorial can be written as n minus 2 into n minus 1 into n minus 4 factorial. Agree? Agree, everyone? So let's see, if we see this, I can say that n minus 4 factorial into, now 4 factorial or 2 factorial, which is bigger? Obviously 4 factorial. So it can be written as 4 into 3 into 2 factorial divided by, right? We have n minus 2 factorial, which is n minus 2 into n minus 3 into n minus 4 factorial into 2 factorial. This is equal to 2 by 1. Now, if you see this, n minus 2 factorial, n minus 4 factorial cancel. 2 factorial cancel. 2 will divide this 4 2 times. Now cross multiply. So after cross multiplying, you get n minus 2 into n minus 3 is equal to 2 into 3. So either you can use your trial and error, or you can solve quadratic. But it's better to use trial and error, right? What should be the value of n? So if this is bigger one and this is a smaller one, a bigger one is 3, so this is equal to 3, right? So n minus 2 is equal to 3. So n is equal to 5, because if n is equal to 5, it will substitute, right? It will satisfy the value, right? So n is equal to 5. Got it, everyone? Tell me. Everyone got this? How to solve these kind of problems? Yes or no? Tell me, everyone. Everyone got this? How to solve these kind of problems? Yes? So n was 5. Okay, very good, everyone. Now think about this, right? After this factorial, this was a basic introduction about factorials. After factorials, we studied about fundamental principle of counting, right? Fundamental principle of counting. Now, when we talk about fundamental principle of counting, we studied addition principle and multiplication principle. So, in addition, we know that if we have two events, one which can be done in M ways and second which can be done in N ways. If either of the two is done, if either of the two, right, then we will add the number of ways. Okay. For example, see, there are 15 students in a class, 10 are boys and 5 are girls. The class teacher select either a boy or a girl for monitor, right? So obviously the number of options the class teacher will have is 15 only. So it is 10 plus 5, 15. Got it? Yes, very good, everyone. Very good. Right? Yes. Now, when we talk about multiplication principle, so if again we have two operation one which can be done in m ways and operation two which can be done in two ways. Okay, right? Or if you have operation three, any number of operation, if you have to do all the operations, like you have to do operation one and operation two and operation three, so you will just multiply the number of ways, right, everyone? Right? Yes, very good. Okay, now let's see. Let's see one problem, everyone. So tell me, this is a problem, right? We have one problem in which the question is how many n-digit numbers can be formed using 1, 2, 3, 4, 1, 2, 3, 7, 9 without any repetition of digit. Okay, right? Without any repetition of digit. If n is equal to 5. So 5-digit number, tell me, 5-digit number without repetition. What's the answer? We have done this. Tell me everyone, we have done this. Tell me everyone, what's the answer? Yes, very good Maudra, very good Suhan, very good Snigdho, very good Priyanshu, Harish. Check your answers, right? So without repetition, so it is 5 factorial now because we have 5, tell me, 5 digits and you have to 5 types of digits, right? So it is 5 factorial. Okay, 120. Yes, very good, Jaita. Very good, everyone. Now, second one, when n is equal to 3. When n is equal to 3, then yes, Priyanshu, very good. Very good, very good. Right? Yes. So if n is equal to 3, so we'll have 5 option into 4 option into 3 option, right? Which is 60. Yes. So easy, easy, everyone. I'll just revise whatever the concept I've studied in last class. Okay. I hope all of you went through the exercise and the examples. Okay. After that, we studied what is the basic definition of permutation. What is the basic definition of permutation? Okay. What is permutation? So permutation is number of ways of selecting as well as arranging, right, R objects, right, out of N objects. Right, everyone? It is the number of ways of selecting R objects out of N objects. The formula of this permutation, okay, the formula of this permutation is NPR, right? NPR. What's the meaning of NPR? It means we are selecting and arranging R objects out of N objects. Right, everyone? So see some problems. Okay, so If we have a problem like this, just see example 14. Everyone see example 14, right? In how many is 5 different red balls, 3 different black balls, and 2 different white balls can be arranged along a row. So doesn't matter if it is 5, 3, and 10 because all the balls are different. Yes or no? Tell me yes or no, right? So total number of ball is 10. So 10 balls can be arranged along a group, along a row in 10 factorial ways, right? That's the answer, right, everyone? Yes, very good. Okay, so these are the easy ones, right? That's why I've shared this video because we have some easy problems. Okay, now this is the basic definition. This is the basic definition. Now, after this, we studied 2 special cases, right, everyone? We studied 2 special cases. What are the 2 cases? Tell me, anyone? What are the 2 special cases? The first case, right? If you remember, the first case in which out of our objects, right? Out of n objects which we are choosing, right? Our objects are same. So, right? For example, Allahabad, right? Now, if we talk about the word Allahabad, I can say that in this word, not all the alphabets are different, yes or no. Not all the alphabets are different, right? So it cannot be n factorial. It cannot be as number of ways cannot be as n factorial because we have few alphabets which is repeating. For example, A is repeating how many times? A, 1, 2, 3, 4 times. A is repeating 4 times, right? L is repeating 2 times. Got it? L is repeating 2 times. So if we are considering n factorial, which is 3, 3, 3, 12. Sorry, 9, 9, right? 3, 3, 3, 9. So 9 factorial. So if I'm doing 9 factorial, I'm clearly making a mistake, right? Harish, B one time only, na? Allahabad. It is B. B, right? Got it? So I'm clearly making a mistake. What mistake I'm making? I'm counting A and L multiple times. Okay, right? So we have A 4 times, L 2 times, nothing else, right? So it will be 9 factorial divided by 4 factorial into 2 factorial. Got it? So this is special case 1. Okay, this was special case 1. Now, if you want to see some examples, now see, Allahabad we already solved, Allahabad we already did, right? Second was Allahabad, so 9 factorial divided by 2 factorial into 2 factorial. In the same way, equation or mathematics, right? You can solve, right, everyone? Tell me, all of you got it? Raise your hand. This is what we have already studied, right? So I'm just revising all the concepts. Okay, I'm just revising all the concepts, right? I'm letting you know that how these concepts are not that difficult. Okay, okay, right? Now, this was special case 1. Okay, special case 1. And here the repetition was not allowed. If repetition is allowed, repetition is allowed, then it becomes quite easy, right? If repetition is allowed, then you don't have to worry. Okay, it will be n into n into n into n into the power n times. Or if it is m repeated m times, so it is n to the power m. Okay, right? For example, if I talk about example, I can say that I hope all of you remember this example. Now tell me, right? You have 10 true and false question. Just tell me. 10 true and false question. True and false question. Right? In how many ways you can answer the paper? In how many ways you can answer the paper? Can answer all questions. All questions. Tell me. Yes, everyone. Very good, very good. Maurya, Pragna, Priyanshu, very good. No Harish, no Shanti. Just think about it. We have already discussed this kind of problem. We had already discussed this kind of problem. Yes, Tinto, very good. So just see, for first question, how many ways? Tell me, for first question, you will have how many ways? Just think about it. For first question, how many ways? Two ways, very good. For second question, how many ways? Two only. For third, two only, and you have to answer all the questions. So just 2 into 2 into 2. How many times? 10 times. So 2 into 2 into 2 into 2 dot dot 10 times. 10 times. It will become what? 2 to the power 10. Got it, everyone? Tell me. Yes or no? Yes or no? Everyone should get this. Yes, everyone is getting this. So this is also what we have studied in last class. I'm just revising what we have studied. Okay, right? Okay, very good, everyone. Very good. Okay, so see some more problems. See question number 19, everyone. See question number 19, right? Even the solution is given, but just have a look. Read question number 19, everyone. Right? So in how many ways 5 letters can be posted in 4 different letter box? So see, in this question, 5 letters, right? Okay, so letters you asked. So for first letter, how many options? 4 options. For second letter, 4 options. For third letter, 4 options. That's why it is 4 power 5. But if the question would have been something like this, right? In how many ways letter box can get the letters, right? Then tell me, then yes, then it would have been 5 to the power 4. Very good, everyone, right? Okay, so see question number 20, everyone. Just see question number 20. Please go through question number 20. Right? So if you see question number 20, I hope everyone gone through question number 20. First one, yes, very good. So see, a person entered the lift cabin on the ground floor, right, of an 8th floor house, right? Suppose each of them can leave the cabin independently at any floor, beginning with the first. Okay? Find the total number of ways in which it can do. So first one, at any one of the 7 floors, right? So if suppose we have 8 floors, right? Just think about this. 8 floors. Now you can be on any floor, yes or no? You can be on any floor, right? So if you are on any floor, okay, right? If you are any of the 7th floor, right? Tell me, and 5 persons. So one person will have how many options? Tell me, one person will have how many options? Tell me, 7 option. Second person will have how many option? 7 option, because obviously he will leave Snigdo, right? It is not saying that a person cannot be in the same floor. Is it saying that it will be on same floor? It should be on different floor? No, right? It is said that it can be on any floor, right? There's no first one. I'm talking about the first one, right? It is said that any of the seventh floor, okay, any of the seventh floor. So first person will have seven options, second will also have seven options, third will also have seven options. So it is 7 into 7, 7, 7 plus 4, 5, which is B. Now this one at different floors. Now this is tricky, right? At different floors. So now first person will have how many options? Seven options. Second person will have how many options? Tell me. Because it should be a different floor now, right? Yes, very good. Six option, very good. Third person will have five options. Fourth person, four option, and fifth person, three options. So basically, right, it is 7 factorial by 2 factorial. Yes or no? 7 factorial by 2 factorial, which is C. Very good, everyone. Right? Are you getting? Are you getting? Okay, very good, everyone. So this was about permutation. This was about permutation. Now, when we talk about combination, right, we studied that what is combination. Combination is basically the number of ways in which anything can be selected, or I can say that combination is the number of ways, right? It is the number of ways in which our object can be selected, right? Or combine a group from n different objects, right? So if we derive the formula, it is what? It is number of, it is basically selection into arrangement, right? Selection of R object out of N object into arrangement of R object is equal to permutation. This is the permutation, NPR. Now selection is your combination. So I can say that combination is represented by NCR. NCR is given by NPR thereby R factorial. This is what we have studied in last class, right? So according to definition, see, I've already told you it can either be represented using exclamation mark or this, right? Like this, okay? Both are the representation factorial. So NCR is NPR by factorial R, which is N factorial divided by N minus R factorial into R factorial. All if you remember, guys, I'm just revising it for you, everyone. I'm revising it for everyone. I hope all of you are getting the concept now. It is being clear, okay? Now, you have to notice that you will use combination only when, okay, you just have to select, right? Now, in last class, we discussed the property. That's what we solved in last class, right? So we discussed few properties. Let's see what are the properties that we discussed. We discussed this property. NCR is equal to NC and minus R. Yes or no? Yes or no? And we discussed this property, right? Second and fourth. First and third is understood. First and third is understood, right? First and third, you don't have to worry about. Okay, so second and fourth are the most important, and we have discussed this. Okay, right, everyone? Right? Now, remaining properties, please try to derive at home. Okay, but we will be using first and second property only. Sorry, first, second, and fourth property only. Now, see this. Example 22. Everyone, just see example 22. Right? I'm giving you 2 minutes. We will take it slow now. Okay? Because we have revised. This is what we will be doing today because we have left till this point only in last class. Right, everyone? We're doing the property only. Question number 22. Everyone, just think about it. Okay. Yes, very good. So question 22 first. So in how many triangles can be formed by joining the vertices of a hexagon? So for triangle, in order to make a triangle, right, you should have how many vertices? Tell me, how many vertices? Three, three vertices. And in hexagon, we have how many vertices? Six. So you have to select three vertices out of six vertices. So it is 6C3. Agree everyone? 6C3, right? Which is basically 6 factorial. 6 factorial divided by 3 factorial into 6 minus 3, which is 3 factorial, right? Which is 3 factorial into 4 into 5 into 6 divided by 3 factorial into 6. So 6 cancel, 3 factorial cancel. So you're left with 20, right? Yes, Pragna, very good. 20. So the first one is 20. Right, everyone? Tell me, right? Got it, everyone? First one is 20. Raise your hand. If you got this, please raise your hand. Okay, very good, everyone. Okay, very good, everyone. Second one, tell me second one. 22 second. What's the answer? Tell me. C, second C, okay. I got those answer. Okay. See, if you don't get the problem right, try to take a special case and try to find it out. Okay. Right. Let's see the hexagon. Right. We have n is equal to how much? N is equal to 6. And see how many diagonals hexagon can make. Right. So if you talk about this, living these two, how many? Tell me, living these two, how many words are left? Right. So if you choose this, the diagonal can either be on this, on this, on this. So leaving three vertices, n minus 3 diagonal from one vertices. And how many vertices do we have? N vertices, so into n. But if I talk about this diagonal, right? And this diagonal will be same, so divided by 2. Okay? Got it? Yes or no? Got it, everyone? Tell me yes or no. Everyone, are you getting how it is n into n minus 3 by 2? This is fundamental principle of counting. You don't even have to use combination, right? You just have to think, right? If you have to choose, you can use like this. See, right? What I told you was basic common sense, right? Basic calculation, and normally this is the method that you can use. Okay, you can see how many lines are there, right? And obviously the sides should be subtracted because sides are not your diagonals, right? Okay, so the answer is n into n minus 3 by 2. Everyone's getting this? Tell me, everyone is getting this? Okay, try question number this. Try this question, everyone. 23. See, even the solution is given, try to think, okay, at least you guys should know what type of question can be asked. Step by step. Take your time, everyone. Please try to solve at least. See question number 23. So we have 8 bowlers, right? Write down the information. 8 bowlers, 5 all-rounders, 2 wicket keepers, right? Now, out of this, you have to choose 11 players, in which 5 batsmen, right? 3 all-rounder and 2 bowler and 1 wicket keeper. So tell me this: all-rounders and wicket keepers, okay? All-rounder, wicket keepers, right? Bowlers. Okay, sorry, there is something which is missing, I guess. Yeah, sorry everyone, half of the question was not visible. Okay. Okay, sorry. This is the question. Half of the question was not visible. So total players, right? My bad. So total players, right? So we have 25 players in which 10 batsmen, 8 bowlers, 5 all-rounders, 2 wicket keepers. Among them, 5 batsmen. So total batsmen was 10. You have to select 5. So obviously the number of ways of selecting 5 batsmen out of 10 batsmen is 10C5. Agree? Agree, yes or no? Right? Then total number of bowlers was 8 bowlers. Out of 8, you need 2 bowlers only. Okay, out of 8 bowlers, you need only 2 bowlers. So 8C2. And we had 5 all-rounders. Out of 5, you need 3 all-rounders. So 5C3. And 2 wicket keeper. Out of 2, we need only 1 wicket keeper. So 2C1. So you have to select batsman and bowler and all-rounder and wicket keeper, right? So this is the answer. Tell me, got it everyone? Tell me, yes or no? Yes or no? Just raise your hand. Okay, everyone, very good. Now 24, let's see question 24. Again, the same thing. A man has 7 relatives, 4 ladies, 3 gents, right? His wife, this is for man, this is for man. Wife have 7 relatives. Okay, wife is also having 7 relatives, 3 ladies and 4 gents. In how many ways they can invite to dinner party having 3 ladies and 3 gentlemen, so that there are 3 of man's relative and 3 of wife's relative. Now, this is very interesting, very good questions. Okay. Now, first of all, we have a condition. What condition? 3 of man relative and 3 of wife relative. Okay. Right. So total gents, total men, how many? 7. Total women is equal to 7. Now, if this condition wouldn't be there, right? So this question would have been easy, which is 7C3 into 7C3, right? 7 number of ways of selecting 3 men out of 7 men, sorry, 3 men out of 7 men, and number of ways of selecting 3 women out of 7 women, right? But this is not the question, right, everyone? This is not the question. Yes or no? There's condition also that 3 of them should be of men. Sorry, so it should be of man's relative, and 3 of them should be of wife's relative, right? Okay. Now tell me, what do you think? You should take a case. In this case, you should take cases. Okay, what cases? Let's see. These are the cases that you should take. Everyone, see this. These are the cases that you should take. Okay, that from man relative, all the 3 are ladies, right? Wife's relatives, all 3 are gent, like means. Then two ladies, 1 gent, and 1 lady, 2 gent. So we have 4 cases. right? So you have to select for all the four cases and then add it. Okay, got it everyone? Just have a look, take a time, take a minute and have a look. Everyone is getting this? Tell me yes or no. Yes or no? Because see, there's a condition, right? Three mans, three wives rated should be there. So I can have a condition, right? Okay, three is a condition. So first case, all the three of man's relative is ladies. So all the three of woman's relative should be gentlemen because we have two conditions. Three ladies and three gentlemen also is one condition. Right? Got it? Then 2 1 1 2, then 1 2 2 1, then 0 3 3 0. This is the only condition, right? Okay, let's see. Next question, everyone. Question 25. Everyone, just go to question 25. See question 25. Read question 25 first. Do not see the solution first. Read question 25 first. Okay, I'm getting answers. Very good, everyone. I got only one answer. See, which last condition, Harish? Which last condition? Last condition was zero ladies in men's relative and three gents. Okay, right? So it is 0 3 then 3 0. Okay, so I hope all of you understood question number 24. Okay, so in question number 24, we have a tea party, right? We have a tea party, 16 people, right, are there, right? And alongside, okay, two sides, long side of table with 8 chairs on each side. So this is a table. So people are here like this and this, okay, right? So 8 chairs, four of them wish to sit on one particular side. So four of them will sit on this side only. Suppose four of them will sit on this side only. Okay, right? Now just think about this. Now, how to approach this? The first thing that you should do, table. This is the interesting question, right? See, there's no formula or calculation involved. Just have to think. Suppose we have 8 people over here. Okay, now four of them, right? This four of them are a group. It will sit right on particular side, this side only. Okay, got it? Now, how many students, sorry, how many people left? So eight will sit this side, eight will sit this side, yes or no? Yes or no? Tell me. Right? Now, according to this, four men wish to sit on one particular side. Four people wish to sit on this side, and two on the other side. Two people want to sit on this side only. Right? Got it? So I can say that this four is among this eight. Yes or no? Yes or no? Tell me, yes or no? Right? So it is selecting four out of eight. Selecting four people out of 8 people, which is 8C4 into. Now, this four people, okay, right? This four people can sit anywhere. Tell me, yes or no? right? Okay, so if we have 4 chairs, right? If we have 4 chairs, so 4 people can sit on this 4 chair in 4 factorial ways, right? I'm talking about this side only, yes or no? Right? I'm just talking about this 4 people only, nothing more. Now come to this 2 people. Out of 8, you have to select two, any two, right? Yes. So it is out of 8 selecting 2, so 8C2. Now these two, right, can sit anywhere here into 2 factorial. Now how many people are left now? Tell me, how many people are left? After removing these 6 people, how many people are left? Tell me, how many? Total was 16. Remove 6. You are left with 10 people. Now these 10 people can sit anywhere, na? Yes or no? Those 10 people can sit anywhere. Yes or no? Yes or no? Yes. So tell me, what is the number of ways of arranging 10 people into 10 seats? 10 people into 10 seats. Yes, very good, Pragna. So remaining 10 people can be arranged on 10 seats in 10 factorial ways. That's the answer, right? That's the answer. Okay, please check everyone. Please take your time and try to understand. Please take 1-2 minutes and try to understand. Got it? Everyone got question 24. Sorry, 25. Raise your hand. If everyone got, raise your hand. Tell me. Everyone got this? Think. If you didn't get, please ask. Okay? Preeti, Shanti, are you getting? Sinchana, Ananya, Anagha, Shreya, Dhruv, Maurya, Kushagra, Zain, Shreya Day, right? Doesn't attend the classes. Abhiram, are you getting? Shankar, Abhilash, Omkar, yes, everyone is getting. Okay, very good, everyone. 8 students absent. Okay, now question 26. Everyone, see question 26. Okay, very good. So see question number 26. 5 married couples means you have 5 male and 5 female. Got it? Yes or no? Yes or no? And it is mixed double tennis. Mixed double tennis. Okay. So, right, you have to select 2 men and 2 women. 2 women and 2 men. Out of 5 women and 5 men. So isn't it easy? Tell me, isn't it easy? Yes or no? Right? So basically it is 5C2 into 3 into, okay, and it is also said that no husband and wife pair is included in the same game. Okay, right? So if you do this 5C2 into 5C2, it means husband wife can also be there, right, everyone? Right? Okay, so first select anyone. Select anyone. So it is 5C2. Select a men. Select a men. Now, if you select men, right, wife of that person cannot be included. Yes or no? Tell me. Yes or no? right? Agree? Okay. So if you're selecting second person, okay. So how many options? It is doubles, right? It is doubles. Means you have to select two men and two women. So since two men, right? Wife of these two people cannot play, right? So obviously, if wife of these two people cannot play, then we are left with three women only. So I've select two women out of three women. So it is 3C2, right? Got it? But the thing is, right? We can do opposite also, right? We can do select woman first, then select men. Okay, right? So this can be done in another one way. So either this plus this again. Either I can write 5C2 into 3C2 plus 3C2 into 5C2, right? Okay, right? If I'm selecting woman first, okay, right? Woman first. If I'm selecting woman first, then I'm selecting male. So it is this, and this is if I'm selecting men first, then selecting woman. Then this. So if you add, you will get this. Agree, everyone? Tell me, agree? Yes or no? Tell me, everyone. Agree? Understood this? Think about it. If you don't get it, please ask. You just have to think. See, in this chapter, you just have to think. That's the beauty of this chapter. Okay, right? So we will study till this point only. We will study till example 26 only. Okay. So all of you, right? All of you have to solve till this example only. Okay. So this textbook that I send, you have to solve only till 26, example 26 plus solve NCRT that I have sent. Okay. Right, everyone? Okay, because the remaining topic, okay, it is taught in next year, right? Not this year. So remaining topic next year. Okay, so please solve till this question number 26 only. Okay, everyone, got it? Now, before completing this, I want to tell you one or two more important concepts, right? What are those concepts? Let's see. Let's see this. Now suppose if I ask you, right? Suppose I ask you a question. Why I'm teaching you this? Because it has nothing to do with any concept, right? It is your basic intuition. Suppose we have uh, 7 boys and 5 girls, right? In how many ways, right? In how many ways they can sit together so that no two girls sit together? Tell me, think about it. I'm giving you 2 minutes. Everyone, think about it. Very easy question, right? It can be solved in one line, obviously. It's permutation combination, right? You just have to think. Think and let me know. I'll give you 2 minutes. Think and tell me, everyone.